Hello, all of you. This is Dr. M.K. Deore, Associate Professor and Head Department of the Physics. Now first, on behalf of my department, I welcome to all of you in the Department of the Physics. Dear students, you have selected Physics as the principal subjects for your career, and I hope you will do the best in future. So, the best luck for your bright career in physics. Dear student, I am going to take your one of the subject, that is the solid state physics, paper second. Dear students, you have studied the different topics of the physics related with the physics in 11th and the 12th standard. Similarly, you have studied the different courses of the physics in first year and the second year B.Sc. Now, such as the mechanics, thermodynamics, modern physics, the electricity and the magnetism, optics and the electronics. Similarly, in T.Y.B.Sc also, in these 2 semesters, we are going to learn the different courses of the physics, such as the classical mechanics, the quantum mechanics, nuclear physics, solid state physics, laser, energy, etc. Now I am going to take the one of that subject is the solid state physics. Students, you know about that the solid. Solid is nothing but a rigid body, and the solid state physics is one of the branch of the physics that deals with the solids. In a solid state physics, we study about the rigid matter or the solid through the methods such as the quantum mechanics, the crystallography, electromagnetism and the metallurgy. The solid state physics is the largest branch of the condensed matter physics. Now then, question is, what do you mean by the condensed matter physics? So the condensed matter physics is the branch of the physics that deals with the microscopic and the microscopic physical properties of the matter. So in a condensed matter physics, we can study the microscopic and the microscopic physical properties of the matter. In condensed matter physics, the physicists study how the matter arises from the large number of interacting atoms and the electrons, and how the physical properties will be changes due to these interactions. Now students, basically the solid state physics is concerned with the crystal and the electrons in the crystal. We know that every solid is made up of the number of the grains. The grain is made up of the number of the particles, and every particle there is the crystal, and every crystal is made up of the number of the atoms and the molecules. So in a solid state physics, basically we are studying about the crystal and the electrons in the crystal. Dear students, the solid state physics begins with the discovery of the X-ray diffraction by the crystal in the early of the year of the 20th century. So the scientists started to study or to do the research in the solid state physics after the discovery of the diffraction of the X-ray by the crystal. The diffraction of the X-ray by the crystal was developed by the German physicist Max Lau in 1912. Nowadays, the number of scientists and the researchers are doing the work on the material science, because there are the huge number of the solids, and we are using that solids for the different applications, from the industrial applications to the domestic application, and also in the electronic industries also. So there is the one branch, and that is known as the material science. So the solid state physics is the theoretical basis of the material science. So the material science, you can say that, is the sub branch of the material science. Hence the solid state physics having the great importance because it has the direct applications in the technology of the transistors and the semiconductors. And students, we know that the semiconductors having the very vital role in the electronic industries. Our Savitribai Phule Pune University designed the syllabus for the solid state physics. It contains the 4 modules. The first one is the crystalline state, second one is the X-ray diffraction and other characterization techniques, third one is the free electron and the band theory of the metals, and fourth one is the magnetism. So in this curriculum, now we are going to learn about how there is the formation of the crystal, what are the different types of the structures, how we can analyze, how we can study the structures. So there is the different methods by which we can analyze, we can study the different types of the crystals. Students, we know that the electron is one of the important elements in the every material. So in case of that, the solid state physics, we are going to study about the free electrons and the band theory of the metals. Simultaneously, now in this syllabus we are going to see about the magnetism, the different types of the magnetic materials, the different types of the magnetizations, and like this. Dear students, you have learned about that the matter in high school levels. So you know about, very well known, you know about the matter. The matter is the part of the universe. The matter is the any substance which has the mass and occupies the space. Now take an example of, this is the chalk. The chalk is one of the matter. Okay, so this is the substance, it having the mass, and so it occupies some space in this universe. So all such physical objects are composed of the matters in the form of the atoms, which are in turn composed of the protons, neutrons, and the electrons. Basically, the matters are get classified mainly in the 3 states. There are again the 2 states, but here we are not going to discuss about these 2 states. We are going to discuss only about the 3 states, that are the solid, liquid, and the gaseous state. We can classify these 3 states of the matter according to the intermolecular force of the atoms or the molecules. The students, we know that the solid having the definite shape, volume, and the definite mass, but the liquid has the definite volume and it takes the shape of its container. But now in case of the gases has the neither fixed shape nor the fixed volume. Then why the solid having the definite shape, definite volume and the definite mass? In case of that the solid, the intermolecular force of the attraction between the atoms and the molecules are very strong, so they are get bound with each other. Only there is a very small vibrations of the atoms and that are about its new position. Due to this strong interaction, they having the proper shape and they having the proper volume. And also very small ovoids are in between the atoms and the molecules. So the atoms having the very high density, and due to that the every solid having the some definite mass. But now in case of that the liquids, the intermolecular force of the attraction between the molecules is weak as compared to the solid, and so it having only the proper volume, but it doesn't having the proper shape. Now in case of that the gases, the intermolecular force of the attraction between the gas molecules is very weak as compared to the liquid and the solids. They are moving far apart from each other, and so due to that the gases has neither fixed shape nor fixed volume. Now here we are going to see about that the solids. The solid is a state of the matter characterized by the particles arranged such that their shape and the volumes are relatively stable. So due to that the strong intermolecular force of the attraction, the particles are get arranged properly, and due to that uniformly, and due to that they having the shape and the volume relatively very stable. The solids can be broadly classified into the two types. The one is the crystalline solid, that is also known as the true solid, and the second one is the amorphous solid, that is known as the pseudo solid. Now the first one is the crystalline solid. A crystalline solid is a substance whose constituent particles possesses a regularly orderly arrangement. Now that means here all the particles are arranged in a regular manner, which having the proper order. The crystalline solids are again get classified into the two types. One is known as the single crystalline solid and second one is known as the polycrystalline solid. In case of that the single crystalline solid is a material in which the crystal lattice of the entire sample is continuous and unbroken to the edges of the sample with no grain boundaries. Now in this picture we can see that all these atoms are get arranged in a uniform level, so there is no any grain boundaries. Now here all these atoms or that the crystals are having the infinite periodicity. Now take an example of, now this is now the crystals, then we can see that all these crystals are arranged uniformly along the one line, and here that there is the infinite periodicity. But now in case of that the polycrystalline solids, the polycrystalline solid is comprised of the many individual grains or the crystallite of various orientations. That means the polycrystals having the local periodicity. Now we can see in this picture that here the number of the grains, this is the one grain, second grain, third grain, like this here. So now here is the broken boundary, that means here is the grain boundary. So the periodicity between the particles or between these grains, between these crystals is limited. That means here is only, so here is the local periodicity. Here is the no long range periodicity as like the single crystalline solids. In case of that, the crystalline solid, when any crystalline solid once heated, it will be melt suddenly. That means we can say that the crystalline solid having the sharp melting point. When it melts, there is the change in its volume suddenly. The crystalline solids having the anisotropic in nature, then what do you mean by that anisotropic property? Now the substance dose shows the different properties in the different direction. Now then that substance having the anisotropic nature. The properties such as the electrical conductivity, thermal conductivity and the like this here. The single crystalline materials, we can take an example of the quartz, salt, diamond like this here. The polycrystalline solids, mostly the inorganic solids are the polycrystalline in nature, including the all common metals, the many ceramics and the rocks are of the polycrystalline materials. Now second type of the solid is the amorphous solid, or that the pseudo solid. An amorphous solid substance is a substance whose constituent particles do not possess a regularly orderly arrangement. Now take an example of this is the glass block. Now we can see here there is the no any arrangement of that the particle. That means here there is the no orderly arrangement of that the particle, which is in a periodic manner. Now in case of that, but in some cases they may possess a small region of orderly arrangement. These crystalline parts of the amorphous solid are known as the crystallite. That means here only in a limited region. Now in this figure we can see that only in the limited region there is some region which having the some short range arrangement, and such a type of that the region of that amorphous solid is known as the crystallites. So we can say that in case of that the amorphous solids, they having the very short range order. We know that if we heat the glass, if we heat the rubber, now then the glass or the rubber will not be melt suddenly. Means it take the some times, means some over a broad range of the temperature it start liquefaction. So in case of that the amorphous solid, we can say that there is no sudden change in the volume of the melting point. So the amorphous solid doesn't having the sharp melting point. The amorphous solids are the isotropic in nature because all these solids shows the same properties in all directions. The properties such as the conductivity, means electrical conductivity, the thermal conductivity and like this here. So the glass, the plastic, rubbers, all are the type of the amorphous solid. Now dear students, our first chapter is the crystalline state, and in this chapter now we are going to learn about the different units, such as the lattice, basis, the translations vector, the primitive unit cell and like this here. Now first of all we are going to see about the first unit, and that is the lattice. Dear students, we know that the solid, that means solid is nothing but the rigid body And the solid is said to be the crystal if the atoms are arranged in such a way that their positions are exactly periodic. Okay, simply you can define that the solid. But now how that the solid forms? How that the solid having that the rigidity in nature? So now in this way we can see that the formation of that the solid. Suppose here this chalk is a solid. If we rub it, if we crush it, now then it will be get divided into that the number of the particles. Again if we crush that particle, again if it get divided into the very very small number of that the particles. Okay, that means here the first one, every solid is composed of that the number of the grains. Then every grains is composed of that the number of the particles here. Now then the particle is formed due to that the number, when the number of the crystals get composed, and the crystal forms due to that the number of the molecules when come close with each other, and the molecule forms when the number of the atoms get composed with each other. And we know that the atom is nothing but that the composition of that the electrons and the nucleus. The electron is revolving around the nucleus, and in that the nucleus there are the number of the protons and the neutrons. So in this way there is the formation of the solid material or the any rigid body. So when you are going to study about the solid state physics, now that times it is very important to know that how the crystal get forms. So the formation of that the crystal is very important, and this is a very basic thing in the solid state physics, and you should know about that the formation of that the crystal. So now in this way here, this is the solid arrangement of that the particles, this is the crystalline solid. So all these particles, all these crystals get arranged in a periodic manner. So now here we are going to learn about how the crystal will be get formed. So the formation, so for the formation of the crystal, it needs the two basic things, two basic parameters you can say. The first one is the lattice and second one is that the basis. So the first we see about the lattice. Now dear students, now take the very popular examples. When the girls drawing the any picture, you can say the rangoli on a paper or on a floor, that times she put up the some dots, and by connecting these dots there is the formation of a very beautiful picture like this here. So here all these dots having a repetitive arrangement, so the every dot having the equal neighbor, means it get situated at the equal distance along in any direction, means along x direction also and along in y direction also. So in case of this two-dimensional picture, after connecting all these dots, there is the formation of a very beautiful picture. Now the same thing, the same concept, we can apply it for the formation of that the crystal. Now another is, now all these points are in a periodic pattern. That means there is the long range order, means ordered pattern. Now take an example. The another is that if these dots are not arranged, now take an example of the stars in the sky. Now they are, we can see all these are in a scattered way. scattered manner. So we can't see all these stars are in a periodic arrangement. But in case of that, this Rangoli, now all these dots were in a periodic manner. So such a type of that these dots are known as, now if we imagine these dots, now these dots are known as the lattice. So for the construction of the crystal, we can imagine such a type of that the points, and that points are known as the lattice points. So the lattice is in general is defined as a discrete but infinite regular arrangement of the points in a vector space. So the every point acts as a lattice site. In another way, you can say that a lattice is an ordered array of the points describing the arrangement of the particles that form a crystal. So here this is the basic requirement to imagine a lattice points on the paper. Then what do you mean by the crystal lattice? An arrangement of the infinite number of the imaginary points in a space with each point having the identical surrounding and is known as the crystal lattice. Means if we imagine all these imaginary points for the formation of the crystal which having the identical surrounding, and that are known as the crystal lattice. Now therefore we can say that the lattice is used to describe the structure of a crystal. So what is the basic thing for the formation of the crystal? So the lattice is the basic thing for the formation of a crystal. Now then, what do you mean by the space lattice? So now in this figure, this is the two-dimensional. But if we apply it for, in case of that the crystal, that is generally three-dimensional. So any solid, means here suppose here this is the solid. So we can see that picture is in a three-dimensional way. So you should know about that the space three-dimensional space lattice. So in a three-dimensional, a space lattice is defined as the infinite array of the points in the three dimension in which every point has the identical surrounding to that of the every other point in that array. So now in this case here, see here, this is the one of that the three-dimensional crystal. Now in this way, if we consider the any point, so what will happen? If we go along the x direction, if we go along the y direction, or if we go along the z direction. So now in this case here, there is the another lattice point will be situated at a equal distance from that point along the three direction. So such a space lattice provides the framework with reference to which a crystal structure can be described. That means here, to describe any crystal structure, we need some frameworks, and this space lattice provides some framework. So now in this case also here, so here is the formation of the unit cell. That means what is that here? If we consider this is the one block. Now then one block acts as the unit cell. So the number of the unit cell get overlapped one over the another, and its neighboring also along the three directions. So there is the framework, and that framework is known as the crystal. Okay. Now then the second parameter that is important for the formation of the crystal structure. So the crystal structure is formed by associating with every lattice point by a unit assembly of the atoms or the molecules in identical compositions. So for the formation of a crystal structure, I have already told you that For the formation of that the crystal, the molecules or that the atom, it should be get composed, it should become with each other. Means what is that here? There should be a unit assembly of the atoms or the molecules in identical composition. So suppose if we consider here, this is the space lattice, means a two-dimensional space lattice. So all these are the lattice sites, all these are the lattice points. Now then, the basis is nothing but the unit assembly of the atoms or that the molecules. And when these unit assembly of the atoms or the molecules get composed with the lattice point, these are the imaginary lattice points. Now then there is the formation of a crystal structure. So now in this case here, the every lattice point get associated with the basis, and basis is nothing but the unit assembly. Okay, that means here the group of the atoms or the molecules. That you can say that the unit assembly of the atoms or the molecules get associated to the every point, lattice point, and hence in this way there is the formation of the crystal structure. So here the lattice points are the imaginary. If we remove it, so what will happen here? We can see that only the unit assembly of the atoms or the molecules, and here is the two-dimensional crystal in a real space. So now in this way here we can see here, suppose if we consider here these are the crystals. So what will happen here? Now in this way, this is consider here, this is one of the unit cell, and the every unit cell there is the number of, that means here the atoms and the molecules get associated with the every lattice points here. When the basis is attached to the every point of the lattice, a crystal structure is formed. Therefore, then what do you mean by the crystal? A crystal is a solid in which the constituent atoms, molecules or the ions are packed in a regularly ordered repeating pattern extending in all the three dimensions. So in this way here we can say that a crystal is a solid in which the constituent atoms, the molecules or the ions are packed, means in this packed in a regularly ordered repeating pattern extending in all the three directions, and that is known as crystal. So I hope you better understand about the formation of the crystal, how the crystal get formed. So now this figure shows how there is the formation, after the formation of that the crystal, how it looks like here. Now in this case here, means here what these are the unit assembly of the atoms or that the molecules. So the crystal lattice is repeating geometric arrangement of the atoms. So here this is the repeating ordered repeating arrangement of that the atoms, and in this way, in case of that the solid state physics, it is very important. The crystal is a very basic concept of the solid state physics, and you should know how the crystal get formed. Thank you.